Imagine you're standing in the middle of a busy international airport. People stream past from every direction. A woman with pale skin and bright blue eyes. A man with dark skin and tightly curled hair. A kid with red hair dragging a suitcase behind him. A teenager with jet black hair staring down at a phone. Face after face. Shade after shade. Most of us would look at that crowd and think the answer is obvious. We're seeing ancestry. We're seeing family histories. We're seeing different parts of the world crossing paths in the same building. And honestly, that's not a bad explanation. But what if it's incomplete? What if, without realizing it, you're looking at something else entirely? What if that crowd is actually a map? Not a map of countries. Not a map of borders. A map of sunlight. Wait, what if the color of your skin, the color of your hair, even some of the traits you inherited from distant ancestors are part of a story written by the sun itself? Researchers estimate that modern humans have spent tens of thousands of years moving through radically different environments, deserts, forests, coastlines, mountains. And through every migration, every detour, every new homeland, one thing remained constant. The same star overhead. The diversity you see today may not simply tell us where people came from. It may tell us how humans learned to survive beneath different skies. To understand why humans ended up looking so different from one another, you first have to understand the problem our ancestors were trying to solve. Because sunlight seems simple. You walk outside. The sun is shining. That's it. At least that's how it looks. Evolution saw something far more complicated. A challenge. A contradiction. Humans needed sunlight. Humans also needed protection from sunlight. Both things were true at the same time. Too little exposure, and the body struggles to produce enough vitamin D, a molecule essential for healthy bones, immune function, and development. Too much exposure, and ultraviolet radiation begins damaging tissues and interfering with important biological processes. So which is it? More sunlight? Or less? That's the trap. The sun gives life. The sun can also create problems. Not a gift. A test. As human populations spread across the planet, they entered environments with completely different levels of ultraviolet radiation. Some regions received intense sunlight year-round. Others spent months beneath cloud cover, fog, or weak winter skies. But the opponent never changed. The sun was waiting above every landscape. Different latitude. Different challenge. Different challenge. Different solution. And the story of human skin color begins right there. Not with identity. Not with categories. With survival. A species trying to solve two biological problems at the same time. And the answer would eventually leave its mark on every human face alive today. Now let's rewind much further. Not thousands of years. Hundreds of thousands. Then beyond that. Fossil records suggest that somewhere between 1.5 and 2 million years ago, our ancestors were living in East Africa beneath some of the strongest sunlight on the planet. Among them was Homo erectus. And if you met one from a distance, they might look more familiar than you'd expect. Longer legs. A more efficient stride. Bodies built to keep moving. Imagine crossing open grasslands under a tropical sun that never seems to let up. Hour after hour. Day after day. Season after season. Here's where things get interesting. Most mammals deal with heat by panting. Humans took another route. Researchers estimate that our ancestors gradually lost much of their body hair while developing an extraordinary cooling system based on sweating. That change allowed them to stay active longer, travel farther, and keep moving when other animals were searching for shade. A huge advantage. But evolution rarely gives anything away for free. Every advantage creates a new problem. As fur disappeared, skin became exposed. For the first time, sunlight wasn't hitting a protective layer of hair. It was hitting living tissue directly. Wait, doesn't that sound like a terrible trade? At first glance, absolutely. But evolution is built on trade-offs. Lose one thing, gain another. The ability to cool the body opened entirely new possibilities for survival. But it also forced our ancestors into a relationship with the sun that no previous human species had experienced. From that point on, skin wasn't just a covering. It was a front line. Before skin became diverse, it first became exposed. Imagine living near the equator around 70,000 years ago. The landscape changes. The seasons come and go. But one thing remains almost constant. The sunlight. Day after day, ultraviolet radiation pours down from above. For the people living there, this wasn't unusual. It wasn't remarkable. It was just life. And that raises an important question. If sunlight helps the body function, why didn't evolution simply make everyone lighter-skinned? Because getting sunlight wasn't the only challenge. Surviving sunlight was part of the challenge too. Inside your body is a nutrient called folate. It plays a critical role in cell division, growth, and healthy fetal development. Researchers have found that excessive UV exposure can degrade folate levels, creating serious biological consequences. And suddenly the story looks different. Dark skin wasn't simply a color. It was a solution. Melanin acted like a biological shield, helping absorb and scatter ultraviolet radiation before it could cause damage. Not perfect protection. Better protection. Not decoration. Defense. Not identity. Survival. Generation after generation, natural selection favored people whose skin provided stronger protection in environments where UV radiation remained intense throughout the year. 3 things mattered: reproduction, development, survival. 3 pressures. 1 solution. Over time, the result was skin rich in melanin, adapted to conditions that shaped human life across countless generations. Today, some people look at dark skin and see a category. Evolution saw a strategy. A remarkably effective one. There's a line worth remembering. Skin color is history written by sunlight. Dark skin was not an identity. It was protection. But humans have always been restless. They move. They explore. They leave. And eventually, some groups began pushing northward through regions near the Caucasus before moving deeper into Europe. That's when the rules started changing. The sun was still there, but it no longer felt the same. The skies were cloudier. The days were shorter. The winters stretched longer. The invisible opponent hadn't changed. The challenge had. Near the equator, the problem was too much ultraviolet radiation. Further north, the problem became too little. Your body relies on UV exposure to help produce vitamin D. Without enough of it, health consequences begin to appear. Researchers estimate that populations living under weaker sunlight faced a completely different set of evolutionary pressures over long periods of time. And suddenly, what once helped could become a disadvantage. That's one of the strangest lessons evolution teaches. Success depends on where you are. A trait that works beautifully in one environment can become costly in another. Over generations, lighter skin allowed more efficient vitamin D production in regions with lower UV levels. Not because lighter skin was superior, because it was useful there. That's a huge difference. Location changed the equation. Latitude changed the equation. Sunlight changed the equation. Wait, isn't evolution supposed to move toward perfection? No. Evolution doesn't care about perfection. It cares about what works. And what works depends on the environment. What protected you in one place could create problems somewhere else. That's not a bug in the system. That's the system. If you're still with me, hit subscribe, because the strangest part of this story isn't skin. It's what happened to hair and eyes. And this is where the story takes another unexpected turn. By the end of the last ice age, some populations living in northern Europe began displaying traits that would have looked unusual to most of our ancestors. Blonde hair, red hair, blue eyes. Features that today feel familiar. But according to current evidence, they appeared surprisingly late in human history. Why? The honest answer is that researchers are still working through the details. But there are clues. Interesting clues. Imagine small communities scattered across cold northern landscapes. Compared with larger populations elsewhere, these groups were often more isolated. Genetic changes that might remain rare in huge populations could spread much more easily in smaller ones. Chance mattered. Environment mattered. Human choice mattered. Some researchers have suggested that sexual selection may have played a role as well. If certain rare traits attracted attention, those traits could become increasingly common over time. Not because they helped someone hunt. Not because they made survival easier. Because humans choose. And human choices can shape evolution too. Wait, isn't evolution supposed to be purely practical? Not always. Once the harshest survival pressures begin to relax, something interesting can happen. Evolution starts experimenting. A different hair color here. A different eye color there. Small shifts. Unexpected outcomes. And over time, those changes contribute to the remarkable diversity we see today. What started as a struggle against sunlight slowly became something bigger. A story of migration. A story of adaptation. A story of possibility. Once survival pressures eased, evolution began experimenting. But before we pat ourselves on the back for solving the puzzle, there's a complication. A good one. Because if the story were as simple as less sunlight equals lighter skin, we'd expect every population living in the far north to look roughly the same. But that's not what happened. Take the Inuit. For thousands of years, Inuit communities have lived in Arctic regions where sunlight can be scarce for long stretches of the year. If our simplified model were completely correct, they should have evolved some of the lightest skin on Earth. Yet they didn't. Wait, does that mean the theory falls apart? Not even close. It means the theory is bigger than we thought. Because sunlight wasn't the only factor shaping human biology. Food mattered too. Researchers have found that traditional Inuit diets were rich in marine foods such as fish and sea mammals, both significant sources of vitamin D. In other words, they weren't relying entirely on sunlight to obtain something their bodies needed. They were getting part of the answer from their environment in a different way. And that's the key. Evolution doesn't respond to one pressure at a time. It responds to everything at once. Not sunlight alone. The whole ecosystem. Not one variable. An entire equation. The Inuit remind us of something easy to forget. Evolution follows the whole environment, not a single variable. And that brings us to the deeper answer hiding underneath this entire story. The easy explanation is tempting. The easy explanation says skin color exists to divide humanity into separate groups. The easy explanation says different shades must represent fundamentally different kinds of people. The easy explanation sounds neat. The problem is that nature rarely works that way. Because evolution was never trying to sort people into categories. It was trying to solve a problem. Actually, two problems. At the same time. Too much ultraviolet radiation could threaten important biological processes, including the protection of folate. Too little ultraviolet radiation could reduce the body's ability to produce enough vitamin D. One side demanded protection. The other demanded access. One side said shield. The other said absorb. And somewhere between those competing pressures, evolution searched for balance. That's why there isn't a single correct skin color. There never could be. A solution that works near the equator may struggle in northern latitudes. A solution that works in northern latitudes may create different challenges elsewhere. Different environment. Different trade-off. Different outcome. That's why human skin exists on a spectrum rather than inside neat boxes. A spectrum of compromises. A spectrum of adaptations. A spectrum of solutions. Here's the idea that changes everything. Nature does not optimize for perfection. Nature optimizes for survival. Not superior. Not inferior. Different. When you look at skin color, you're not looking at ranks. You're looking at strategies. Each shade is a different answer to the same ancient question. How much sunlight is enough? And how much is too much? Skin color is not about categories. It is about trade-offs. And this is where the story quietly shifts. Because it stops being about distant populations and ancient migrations. It becomes personal. It becomes about you. Right now, as you're listening to this, your body is carrying traces of decisions made long before your name existed. The shade of your skin. The color of your hair. The way your skin reacts after a day in the sun. The ease, or difficulty, with which your body produces vitamin D. None of these appeared by accident. And none of them appeared overnight. They are echoes. Researchers estimate that thousands of generations separate you from the people who first faced these evolutionary pressures. Yet pieces of their story are still traveling with you. Wait, isn't your body just your body? Not exactly. It's also an archive. A living archive. An archive of migrations. An archive of adaptations. An archive of survival. Imagine walking through a museum where every room tells part of humanity's story. Then imagine discovering that museum isn't a building. It's you. Your skin contains information. Your genes contain information. Your biology contains information. Not written in sentences. Written in traits. One of the strangest things about being human is that history didn't stay in the past. History entered the body. Maybe that's why evolution feels so personal. Because it is. Your ancestors adapted so that you could exist. And every time you look in the mirror, you're seeing more than a single individual. You're seeing the outcome of countless encounters between human beings and the worlds they inhabited. Your body remembers journeys you never took. Now think back to that airport from the beginning. People moving past one another without stopping. Different skin tones. Different hair colors. Different features. At first glance, it looks like a collection of separate stories. But the closer you look, the harder that idea becomes to defend. Because every person in that crowd carries evidence of the same challenge. Every person descends from ancestors who had to negotiate with the same sun. Different solutions. Same problem. Not separate stories. One story. And that's what makes human diversity so fascinating. The traits we often use to distinguish ourselves are also reminders of how deeply connected we are. Over tens of thousands of years, one species spread across an entire planet. Some populations adapted to intense ultraviolet radiation. Others adapted to weaker sunlight. Others followed paths shaped by geography, isolation, diet, chance, and opportunity. Each path left traces behind. Visible traces. Living traces. Human traces. Now zoom out for a moment. On a small planet orbiting an ordinary star, a species of primates learned how to survive beneath different skies. And in doing so, that species turned sunlight into biology. Light became pigment. Environment became adaptation. Adaptation became diversity. And the evidence is still everywhere. In every crowd. In every family. In every face. We carry sunlight in our skin. Subscribe.